Hello everyone, welcome to my YouTube channel. So today our topic will be probability, and in this first video I'm going to basically teach you the principles of probability that you ought to know in order to pass an aptitude. So what's probability? First of all, probability is the chance of occurrence of a random event. So the chance of something occurring, that is a probability. The chance of raining on a given day, that is a probability. It's a chance of occurrence of a random event. So what is this random event? Random event. Random event, this is an experiment when conducted repeatedly does not give the same answer. An example of a random event can be me getting a coin and tossing it. The first time I get heads, I toss it, I get tails, I toss it, I get tails. That is a random event. And then we also need to know what an event is. An event, this is an outcome. This is an outcome of an experiment. Are we together? So an event is basically an outcome of an experiment. And to understand these events, I'll draw a Venn diagram that will illustrate the meaning of these events, while I'll also be giving you examples. So this is probability of maybe A, and probability of an event B. Probability of A may be maybe if I have a coin, and A will be the heads and B will be the probability of a tail. Are we together? So we are going to start with, let's see what is the union here. If we are to get maybe probability of A union B, and we want to get the probability of this and this, that means we have to add probability of A and probability of B. So we add probability of A plus probability of B. But we have to exclude this intersection in order to avoid double counting. So that is the basic formula of probability of A union B. Are we together? So one of the basic tricks that I normally was taught is that we can have here probability of A, and this is probability of A complement, and this is probability of B, and this is B complement. So here it will be A intersection B, here will be A complement intersection B, and this will be A intersection B complement, and this can be A complement intersection B complement. So if case they ask you probability of A, this probability of A is the same as having probability of A intersection B plus probability of A intersection B complement. Are we together? You can actually see it here, but let's not take time, just you need to know it. If they ask you maybe maybe let's say probability of B complement, the same as probability of A intersection B complement, plus you take this line now, probability of A complement intersection B complement. You could try it out. If they say A complement, a complement is the opposite of A, you would take this line. B, you would take that line. So let's see the events. We have what we call mutually. Remember, we are looking at the events. Mutually exclusive events. Are we together? These are events that cannot occur at the same time. For example, it may not rain at the same time when it is shining, or maybe the probability of tossing a coin, you either get a heads or a tails. In case you toss a coin, that can be a perfect example. You cannot get a head and a tail at the same time. Are we together? So that is an example of a mutually exclusive event. That means that the probability of getting a heads maybe or a tails will always be 0. You cannot get them at the same time. So their intersection is always 0. That is the principle of mutually exclusive events. So if we are to look at their union, that means if these were mutually exclusive, there would have been two circles. This is probability of A and probability of B. Are we together? And their union would have been probability of A plus probability of B. The intersection is 0. We see there is no intersection. And let's go. Other events that we have what we call independent events. These are events. So independent events, these are events if they happen. So independent events, these are events that the happening of one event, is not affected by the happening of another event. Are we together? For example, if I toss a coin the first time and I get a heads, and the next time I toss, I get a tails. Are we together? Me getting a head in the previous one does not affect me getting a head in the next one. If I roll a dice, the first time I get maybe a 1, and I roll the next time I get a 5. I roll the next time I get a 4. The 1 did not affect the 5, and the 5 did not in any one way affect the 4. And this is the one that they normally use in such events, like when they tell you they have 3 balls and 5 red balls, 4 3 balls. 1 is selected at random, and what they normally use this principle of independent events. And for it, the principle here is that A intersection B is always probability of A times the probability of B. And we are going to see an example on this. Then lastly, we have what we call the exhaustive events. So these exhaustive events, that means that all possible outcomes of an event are the same. Are we together? So, for example, if I throw a dice, I can get a 1, a 2, up to a 6. All the outcomes are known here. They are exhaustive. You cannot get a 7. If I throw maybe a coin, I'll either get a heads or tails. The outcome is known. Are we together? Those are exhaustive events. Then lastly, we are going to look at the sample space. Sample space, this is a set containing all outcomes, all possible outcomes of a random experiment. An example can be if I have a coin and I toss, I can either get a head or a tail. So its sample space will be a 2. If I toss a die, I either get 1 up to 6. Are we together? Its sample space will be 6. Are we together? Then what is now the probability? Probability, that means probability is expected outcome over the sample space. For example, if I say I have tossed a coin, the probability of me getting a head, if I toss it once, I can get a head once out of the sample space, which is 2. Possible outcomes is either a head or a tail. Are we together? If I toss a dice, the dice once, the probability of me getting a 2 will be 1 out of the sample space. All possible outcomes are 6. Thank you, guys.